Let us apply our statistical estimation technique to the actual data. So let us solve a problem for proportions. So let us say a poll of 100 Canadian adult Twitter users found that 52% of them get their news from Twitter. The standard deviation of the Canadian adult Twitter users proportion was 2.4%. We want to construct a 99% confidence interval for the fraction of Canadian adult Twitter users who get their news on Twitter and interpret the confidence interval in context. So what is the sample size here? The sample size here is 100. What is the standard deviation of the proportion for the population? 2.4%. So what will be the standard error of proportion? The center limit theorem tells us the standard error of the sample statistic is sigma by root n. So is equal to sigma divided by square root of n. Right, that's 0.24. No, it should be square root. Yep, so 0.24%. So what will be the confidence level that we are going to work with? 99%. Okay, it's already there. So if you know the confidence level, we know what is the significance level. The significance level is 1 minus 99%, which is often referred to as alpha, or the size of the test. Now this 1% will be split on the either side of the tail. So 99% will be in the center, 0.5 in the left tail, and 0.5 in the other tail. So we will compute the alpha by 2, divide by 2. Now we know the proportion of Canadian adults in the sample of these 100 people is 52%. So what will be the Q, which is 1 minus P, is equal to 1 minus P. Now to apply the center limit theorem for estimation, we need to apply the or test for the success failure condition that NP should be greater than equal to 5. So let's see how much is NP multiplied by P, that is 52, is equal to 100 times Q, which is 48. So both of them are greater than equal to 5, so we are good with the application of the center limit theorem in this context. What will be the error, margin of error that we allow for, which is given by z times standard error, is equal to z. And how do we compute z? Okay, so we want to know the z value corresponding to 99.5%. I must increase the significance level here so that we are able to see that 0.5. So we will compute the norm. Dist gives us, given the z value, it tells us the area under the curve. Now we are going to use the inverse, where we specify the probability and it gives us the corresponding z value plus 0.5. So this is your z times standard error of p, which is 0.24, so which is 0.62%. So what will be the lower limit? Will be the point estimate p minus the margin of error. That will give us the lower bound on the z, on the p. Actually, instead of z, I must actually use p here. And the p upper level is the p plus the point estimate plus the margin of error. So we can see the true population parameter will lie between 51.38% and 52.62%. All right. Let's apply into a context of mean now. Here, instead of calculating the interval, we will calculate the appropriate sample size. So a researcher wants to estimate the mean systolic blood pressure of adult Canadians. She wants to be 95% confident that her estimate is within plus minus 3 mm of the mercury or the pressure of the true mean. So from previous studies, it is known that the population standard deviation is 12 mm. So what sample size should she use to ensure that within this interval she will capture the true population parameter? The confidence level given here is 95% and the standard deviation of population is 12. Since we know the confidence level, we can compute the significance level, which is alpha, and since we know alpha, we can find the area under the either tail. I must increase the level of significance here. Now let's determine what is the z value corresponding to alpha by 2. That will be 95 plus 2.5, that is 97.5, is equal to norm is inverse 95 plus. We can compute for the lower side also, which will be 0.025. So which if we compute, we will see it will be negative norm, because the upper end is 97.5 and lower end is 2.5. If we compute for this, we will find the area to be minus 1, the z value to be minus 1.96. Right? So we can choose either of them. Now, what will be the margin of error? Which is z times standard error. Now we know the population standard deviation is given to us as 12. We will divide it by the sample size to determine the, we need to determine the sample size. Okay, so the margin of error is 3, plus minus 3. We know that n equals z times sigma divided by e power 2, right? So we have the values with us. So let's say is equal to z times sigma divided by e, the whole thing raised to 2 will give us the n, and which is 61.46. We can approximate it as 62. So we need 62 sample size to guarantee a 95% confidence level and a error margin not more than 3, within 3 plus minus 3.